Okay, thank you everybody for joining to our presentation, and thank you Texas Summit for letting us be part of this amazing conference. Today we're going to speak about different vulnerabilities that we found last year in the 2020 that will allow ultimately an dedicated attacker to basically compromise, full compromise an SAP system. So hope you enjoy our presentation. Who are we? My name is Pablo Artuso. I'm today with Ignacio Favro. We both work as security researchers at the Onapsis Security Research Labs. We both from Argentina. And yes, we enjoy our day-to-day basically doing vulnerability research, penetration tests from time to time. And at the bottom of the screen, you will find a link to our GitHub, to our team GitHub, where we are gonna publish. We are gonna be publishing our latest advisories. So if you are curious about them, just I recommend to go there. This is our agenda for today. First, we're going to start with an introduction to ACP Word. Then we're going to go in deeply details about the different vulnerabilities that we found last year. We have a special chapter talking about threat intelligence campaign that we were part of last year, and it's really, really interesting. And finally, some conclusions. So let's start with introduction. Why ACP? Why we keep insisting on our ACP security? Well, ACP is one of the largest companies in the world, and the solutions that ACP develop basically are business solutions, are being used by the most largest companies in the world. So if you go to the Fortune 500 oil and gas, for example, companies, all of them are using ACP for the daily business. ACP manages financial resources, human resources information, stock resources, what else? Business processes. So a lot of different important and critical information of a company related to the business goes through an ACP system. So that's why we believe that ACP system uh, take should be taken more seriously when it comes to security. Um, Today, as I already told you, we are going to speak particularly about a layer that is part of hundreds of different solutions of SAP, which is called the SAP NetWeaver layer. This layer is a base layer for a lot of different solutions, and this means that a lot of ACP solutions are built on top of this layer, right? So they share this layer. In particular, the SAP NetWeaver layer could be found in two different ways developed in Java or developed in ABAP. Today, we're going to be focusing specifically in the Java NetWeaver layer, right? And here, for example, we have very well-known solutions of ACP like the Solution Manager, the Landscape Manager, the Enterprise Portal. These are some of the solutions that are based on a SAP NetWeaver Java layer. From an architecture point of view, this is how an application server, a Java application server looks like, right? We can see there that we have two different type of instances within Java. We have what is called the Java instance and the central instance, right? The central instance is unique per system, so every system we have only one central instance, and we have particular processes running in that central instance. And besides that, we have multiple Java instances, as many as you want, right? Inside each of the Java instances, we will have some different processes. In particular, as you can see in the slide, we have the ICM, which is basically the HTTP server from from each Java instance. And this means that the way to communicate to these solutions or to these systems basically is through the HTTP protocol, which is really well-known protocol. On the other side, if we were discussing out ABAP application servers, we're going to see different binary protocols and custom protocols, which is a little bit different here in Java. Besides the ICM, we have what is called the server process. So within the Java instance, we have I think that is the smallest unit of processing, which is the server process. Each server process of the Java system has its own cluster manager, as you can see there on the right. So I just want to mention this because we're going to go back to this in a couple of minutes. Another interesting feature or characteristic of the ACP Java systems is that they are usually exposed to the internet. This means that sorry, they are not usually exposed, but if you grab all the systems that are exposed to the internet, the ACP systems, most of them are ACP Java systems. And basically, from my point of view, this is because they are uh, HTTP based, so this means that they are easily being exposed. But besides that, there is a particular solution based on SAP Java NetWeaver, which is called the Enterprise Portal. The SAP Enterprise Portal is basically one of the solutions that was developed by SAP in order to be exposed to the internet and allow external users to log into the system through the Enterprise Portal. So we are gonna uh, go back to this again in the future chapters because this is a crucial and important information for the rest of the talk. Next chapter is about our findings 2020. So let's continue with the first of the vulnerabilities that we have for today, motivation. So why we decided to start looking for this bug? In the early 2020, on March 2020, together with a friend, Ivan, we discovered a bug that was really critical in the SAP Solution Manager. We finally combined this with another vulnerability, and we delivered a talk in Black Hat USA last year. I really recommend it to you go there if you are interested about these topics, because we finally got root shells from every SAP server that was part of the SAP landscape, so it's really interesting. But besides that, the important thing was that there was a bug in the SAP Solution Manager that was basically a web service exposed without authentication. So after that, we started asking to ourselves, okay, are there more web services exposed without authentication? What about the web services that are exposed at the SAP NetWeaver layer? Because this one was specifically from the SAP Solution Manager, but the SAP NetWeaver layer also exposes web services. So I started creating a tool capable of list all the web services, decide if or decide no, check if they need or not authentication, and of course this in an automatic way because it was a tool. After a couple of weeks or months, I finally got the running that tool, and once I ran it, it gave me a lot of different web services that were exposed without authentication. And among all of them, there was one that was called CTC Web Service SI, which is our main topic for this analysis. So this endpoint is a SOAP endpoint. So for those who are not aware about SOAP, it's just a really interesting protocol based on XML that allow basically executing methods remotely. And if you can see in the middle of the screen, the first image, we have all the methods that are available to be executed or to be used uh, through through calling this SOAP endpoint. And among all of them, there is one that is called execute, which seems to be interesting. On the right side of the slide, you have the let's say the body of the packet that you should send in order to execute that method, and also you have all the parameters that they are needed: the identifier, a context messages, and resource. So at this point, I didn't know how to use this, but what I did know was that all this is developing in Java, and Java is easy to decompile, right? So I decompiled the code and I shift from a more black box, let's say, strategy to a more white box one. And I found the implementation of this web service. In particular, you can see there the execute function having or receiving the three parameters that we were talking about before. And what we have there are the data types of each of these parameters. So this was really interesting and really helpful because I started looking for that data types in order to find the definition of them. But instead, I found a snippet of code that was actually creating a resource identifier, and it had all the different parameters that this resource identifier constructor received. So this was really useful because I could just grab these three parameters and use them in order to call through a stop message the execute function, right? So you can see there the body of the packet of the SOAP message that I had to send using all the three parameters that I grabbed from the snippet of code. And once I send that, I receive an ID as an answer. So I didn't know what this ID was, but after playing a little bit with other methods like events available or read next event, I saw that they were asking for a parameter that was called session ID. So I think I did some synapses, and I realized that maybe this ID was exactly that session ID that these methods are asking for. So I started looking for that number, that particular number in the OS of the SAP system, and I found a log that was talking about that specific session ID. And when I realized that log was related to the configuration wizard application. The configuration wizard application, I didn't know what that application was. I knew that was part of the NetWeaver administrator panel. So I entered to that, as you can see in the images. And within the running configuration task section, I found a seems to be a task, a configuration task that was running over there and had the session exactly the same session ID that I received as an answer. So just to recap here, I didn't know what the configuration wizard was, so I looked for it, and I have a quote here from SAP documentation, which the most important thing is that it says it makes the technical settings in an automated way. Sorry. So it seems that it does really interesting things, right? Like the technical settings, and also in an automated way. So it seems like somehow related to scripting or something else. Some part, if we go back to the image, we can see that there is a task name over there, right? There is a create users. So somehow it seems there are more tasks, more possible configuration tasks, and some part of our message that we send through SOAP decided that we have to use that configuration task. And if you pay attention to the parameters, you can quickly see that most probably the good candidate it was the last parameter. Also, that parameter seems to be a path, right? So I went to the operating system and tried to look for that possible file, and I found it. It was there. It was exactly in the same path that parameter said. So it was really interesting because, okay, now I have the file in order to understand what a CPROC is and what basically that file is. But besides that, I look for that extension CPROC, and I realized and I found that there was more than 500 CPROCs. So at this point, I didn't know what a CPROC is, but I know there are a lot of them. But seems that this CPROC, the SPC user management, is the one that basically decided what configuration task to run. So I opened that file and I found this. Of course, as you can see, it seems to be something XML based. Here we can find the description, that is the create user, the thing that we appear in the image. We can see some tags like for each inbox service input that makes the idea that is something related to scripting. I found also this, which is a message, something that it will be helpful later on. That is called user details, and as you can see in the first part of the file, we have something commented. We have user details and some information that I don't know what that means. And finally, we have within the expression tag, we found like some dash user dash Java or ABAP dash user dash username. And if we can see here inside the user details tag, we have the same 4 tags. So it seems like somehow this is accessing the data which is over here. So what we can think is like the user details is like kind of the parameters that we have to put here or to provide to this kind of script. And here in the pink squares, they will be grabbing that values from the parameters. These are just ideas. So what we know about CPROCs? CPROCs are XML based. There seem to be scripts, and they seem to receive parameters. How? Well, if you remember the snippet of code that I already told you, behind that, sorry, the code also was creating a CTC context message with this string that is the same string that we were talking about before. This user details and all this piece of information that was part of the commented section. So this was the way to provide parameters to this script. And here, as you can see, they were executing with the identifier that we had before, and the input with this a CTC context message data type. So now we have all things to test this through the SOAP endpoint. However, I had some issues there trying to make that work. So what happened finally was that I shift to a more simpler cproc. I found another one that was much more simpler. It has a message that is called delete user. Here we can see that we have access, that this cproc is accessing the root username tags within the parameters. And it seems that this cproc is deleting a user, right? Just providing this message. So now we have the knowledge on how cproc works, at least basic knowledge, and then we have the cproc, so let's try it. So first of all, I create a new user in the system that was called test recon user, and then I craft the SOAP request that we have to send with the corresponding, of course, parameters. Here we are choosing the cproc or the task that we want to use. The delete user is the name of the context message and the content of that message, right? That, remember, it has to be base64 encoded. We got an ID, and this ID says that it has almost the same name as the other one. It finished successfully, and when I went to the system to list all the users, test recon user wasn't there anymore. So what happened? So specifically, the script executed successfully, and we deleted a user. But in more general terms, what we finally did was we were able to execute a configuration task without any kind of authentication. And if you remember, we have 500 more configuration tasks, right? So at this point, I say, okay, now it's time to look for the most critical cproc, right? So in order to do that, I had to learn a lot more about cprocs. I had to go more in details about all how they are built, what that means. I mean, the nature of steps. I mean, each cproc is based on steps. They can have 20, 50 steps. They clearly are scripts. You can skip some steps if they are not interesting for you. And also, in order to talk and to understand how the process is going, basically it's working, there is a lot of things like not a lot of things, a framework event driven that I had to learn how to read an event, how to provide a new event. So after a couple of analyses, after a couple of days doing some analysis, I found maybe one of the most critical cprocs that, at least from my point of view, it was really, really interesting. It had more than 20 steps, but within the first 2 steps, it did all the critical things that we needed. This was the code of the cproc. The name was create Java users. In the first step, it will create a user with a password that you provided and, of course, the username. And in the second step, it will assign a role to that user. And which role? Well, the role that you provide also as parameter. Here is the template of the message that we can send. The user, the password, and the role that we want to that user. So stop talking, please. Go directly to the demo. So here we are going to see a demo of this. First of all, the attacker will try to log into the system with the Texas admin user. This user doesn't exist yet, so it will fail. Perfect. So now what is the attacker going to do is basically execute a script that is exploiting this vulnerability called RECON. Has to provide, of course, the host, the port, the username, and the password of the user that it wants to create. And the administrator role that is the role that is going to be assigned is basically hard coded inside the script. So as you can see here, it's executing that cproc, the create Java users, and we only need the first 2 steps. Then we can cancel the execution because we don't need anything else, right? So now we are going to try to log in with that user again, and this time it works because the user was created. Now, just you to be sure, if we list the user roles, we are going to see that it has administrator assigned. So what happened here? Basically, an unauthenticated attacker with access just to the HTTP port of the SAP Java system was able to grab an administrator user and potentially full compromise the entire SAP system. So let's talk about protections. And in particularly, when we talk about patching, SAP releases the patch within the first month after we submit the vulnerability, right? So this talks really good about the PSRT team because I'm not sure if you all are aware about this, but SAP releases security patches for their solutions every second Tuesday of every month. And yes, they release the patch within the first month. So in the next possible patch day, the patch was already out. So this was really quickly, and well, it talks really good about the PSRT team and of course all the developers that are involved. But besides the patch, SAP also released three different notes talking about extra information on Recon, explaining to their customers how this vulnerability worked, where it was, an FAQ talking about how to install the patch, explaining again the different questions or the most simple questions that could arise. And a third note that talk about workarounds. SAP knows that sometimes it's not easy or not so quickly to implement patches in SAP systems. So they also release a workaround that is basically how to disable the application in case you are not using it. So yeah, for SAP, this was really important and they address it really well in terms of protections. Talking about extra protections besides the one provided by the vendor, also the community of Snort created rules for that, and the most well-known IPSs and firewalls developed new rules to address this vulnerability. From Onapsis, we developed a free assessment tool that you can download it directly from our GitHub, or you can also use our cloud version from our web page. In terms of publication, this attack was in some of the most important resources in terms of news, like CDNet and Dark Reading. But the most interesting thing is that different countries, different certs from different countries issued alerts about this topic, and primarily because there were a lot of companies within their countries like that uses this software, SAPs. And in terms of public exploit, well, we have three of the most, I mean, these were the three most common. Chipik, I think, was the first one that releases a working exploit, and Sustainer is a really well-known security researcher that usually he developed Metasploit modules. So I think that within the first or second week, they already had a fully functional working exploit within the Metasploit framework. And now I will let Ignacio continue with the talk.
Thanks, Pablo. Hi, everyone. I'm Ignacio, and I'm really glad to be here today speaking about the Cluster Manager P2P Communication research. And the reason behind this research was, first of all, that an SAP system is a software platform, which means that it's made of several components, with some of them highly coupled each other and exchanging messages or opening ports for external connections, for example. But also, as Pablo said before, the SAP Java system are more frequently exposed on internet, becoming a really interesting product to analyze. So we decided to see what is open by default. With a list of services that has open ports and waiting for connections in all interfaces, and filtering out those that we already know what it is, looking for the fresh target, we establish a connection with the remaining ones, and one of them gives us this SAP Cluster Manager banner. For us, was quite new, and not a lot of documentation were available at that time. So we decided to interact a bit more with this service, playing with different payload size and also sending back, for example, the banner that we received when we established the connection. And for this last case, the behavior of the service was quite different. It keeps waiting for more information after this banner. Checking the process syscalls, we realized that what it seems to be a two-step communication, because first the service tried to read up to 47 bytes, which is the same length of the banner that we get, and after that more data is required. Also, analyzing the log's reaction to our different payloads. In the first case, we have an exception when we sent a pure A payload, a full of A payload, and a handshake Java class and an unsupported protocol version is printed out in these log files. But if we send the banner, we send back the banner that we get when we establish the connection and append some A's at the end, another Java class throw an exception about a corrupted header and a checksum. So we decided to take these two Java classes as our starting point for this analysis, and we were able to identify all of the fields that make up these messages. On the left side we have the handshake, which is 47 bytes as we said before, and after that we have the header of the message of 48 bytes, which was new for us in that moment. And as we can see, we have a variable length body for this message, and this body will be processed by different kind of services. This is the role of this service ID field in the header of the message. This service ID will pick the listener that will be in charge of process or handle our request. And this internal message listener is an interface, and we found around 40 implementation of this message listener. Some of them with highly critical and privileged action, as we will see as follows. Here we have a scenario in which an attacker which has direct access to this cluster manager, no authentication is required here, so it can interact with any of these service IDs or any of these internal message listeners. First, we will talk about the SLD listener, which gives us information about the system or system properties. For example, the username that is running this SAP system, and also the global directory and version about the Java, about SAP, and other info about this system. But also we found this database manager listener, which allows us to modify some connection parameters. For example, the max connections allowed to be established. So if we set this value, for example, to 1, only one connection will be available, exhausting the available connections for real users and leading to a denial of service, for example. And the last one for today is this JMX listener. JMX is a Java technology, is not an SAP thing, which allows, to be short, basically to register and invoke dynamically something called mbeans. It is a Java bean with some specific characteristic for this technology. It's not really interesting for our analysis today, but as we can see here, we can invoke and query all the mbeans that were available in this SAP system. And we found around 130 mbeans registered by default in an clean SAP installation, and some of them with high privileged actions or critical actions. And we will see the effect of these, basically of these three managed beans and its methods. The first one is the single sign-on, which allows us to add a trusted ticket issuer. This means I can register myself as a single sign-on ticket creator with my public key, and after that with my private key I can create my own single sign-on authentication tickets and authenticate inside the system as any kind of user. And Pablo will talk about this configuration in the system, about create HTTP alias and enabling directory listings. This kind of configuration can be performed also through this cluster manager and its service listeners. Now we will show you a demo about this JMX listener and adding a trusted system to create single sign-on tickets. Here we are going to start from an already logged in user just to show you the configuration that can be achieved through this cluster manager. As we can see, no trusted system is available so far. So first the attacker checked the connection is possible to the cluster manager, and after that we'll try to inject its own system or its own public key as trusted. First, the script will try to identify the message ID that is required. Once we get this, we'll try to identify the service ID, which is running the JMX listener. And after that, as we can see here, now we have a new trusted system to create logon tickets for single sign-on. About protection measures to this service, SAP released a note basically adding authentication to this cluster manager service. But also it's a good option here to first configure the message server ACL to allow connection only from IP addresses for instances of the same SAP system, and also end user usually don't need access and interact with this cluster manager. So firewall restriction, dropping connection from end users, only allowing from, as I said before, instances of the same SAP system is a good option. Next, Pablo will continue with the last vulnerability for today.
So yes, thank you, Ignacio, and let's start with the final vulnerability of today. First of all, motivation. So either with the cluster manager or with Recon, an authenticated attacker is able to grab a user, an administrator user of the ACP system, right? However, administrator users are not able to execute OS commands. And as security researchers, when we start looking for vulnerabilities, we want to find a pre-auth remote code execution, right? So in order to achieve that goal, let's say, we have, we have half of that goal. We already know how to, without authentication, grab a user of the system and of the system, sorry, and not any user, but an administrator one. So we have to fill that gap. We have to find a way to execute commands, but being an administrator user, which is something that should not happen, but is most probably to find it that finding a pre-auth remote code execution from scratch. So we start our search with the NetWeaver administrator application. This application holds a lot of different and several applications within this application that is part of the SAP NetWeaver Java layer and allow you to control a lot of different stuff from your SAP system. You can control connections, you can control configurations regarding applications, you can control connectivity, like give authentication to some part to the other part, etc. In fact, the configuration wizard application, the one that is related to Recon, is inside this NWA. Another application that is part of it is called Java HTTP Provider Configuration. And within this application, you can configure several things related to the HTTP server. For example, you can define application aliases. Application aliases are basically a path, a short path, in order to relate an application. So if you want to define, I don't know, a dash ASD, and you want every time that somebody enters to ASD, you're going to redirect it to an application, to a particular application that is running on your system. Well, you can define that. You can also define aliases. Aliases are the same thing. I mean, you can define an alias like the previous one, dash ASD, but instead of related to the application, you will relate it to an operating system path. So you can, for example, link it to a dash temp directory. Also, you can define virtual hosts, of course, the cache usage, and you can activate directory listing. So if you pay attention, I mentioned directory listing and aliases, right? Combining those two things, what you could do is basically you activate an alias in order to uh, link a particular dash ASD, for example, a particular URL to an OS directory or OS file, and then browse that file because you have the directory listing activated. Is that possible? Yes, it is possible. And with that, an administrator user already will be able to read files from the OS. But if we want to execute commands, we need something else, right? And one option is to upload a web shell, for example, place it in the OS, and then reference it with this technique. But how we can upload a web shell? Well, we start looking for ways to upload a web shell, and we finally found a candidate application. This application basically allows you to upload a configuration file inside a zip file. But if the file that you compressed and you upload doesn't follow certain structure, after the compressing, the application will read that file, will fail because again it doesn't follow the correct structure, but it will never delete that file. And moreover, it will return an error saying, hey, the path where I decompress it and the file doesn't follow, or this file is not found there, blah, blah, blah. But the important thing is that it also gives you the path. So with those two things, what you can do is basically upload a web shell and then grab that path and use it as an alias. So the full exploitation will work like this. First of all, log in as administrator, enter to the NW application, activate the directory listing, upload this configuration dash web shell over there inside the zip. Once it fails, the web shell will remain over there and it will return you the path where this web shell was uploaded. Use that to create an alias of the system, and you can reference your web shell, and finally you will be executing commands as the SAD ADM user. So demo time, let's see this in a video how it works. This video will be a little blurred because there is not a public exploit about this, so it's better to keep some things private still. So here the attacker is activating the directory listing. Now it's defining the alias. The alias will be named java underscore rse underscore poke. Here is checking that basically that directory or that alias is an empty directory so far. Now we are gonna blur, but here what is happening is the attacker is uploading the web shell to that particular directory, and here we have it, the web shell.jsp. So now it's a matter of executing the command that we want, for example, the who am I, and this will return the SAD user that is being used by the system, in this case, RD1 ADM. So this basically means that a user with administrator privileges was able to execute OS commands, of course, abusing this vulnerability. And if this vulnerability is combined with Recon or with the cluster manager issue, then it will be a fully functional exploit of a pre-auth remote code execution. Let's talk a bit about protections. About the patching, again, SAP patched this vulnerability in the first patch day possible. This means within the first month. I mean, we submitted that vulnerability, and within the first month it was already patched. So this talks really good about, of course, the PSRT team and all the technical team involved in developing the protection, but it also talks really good about SAP in general because it's clearly how they have been improving in terms of security, how they are putting effort into protecting your customers, and of course creating or developing a more secure software. In fact, we can see that we see that really often because each day is harder and harder to find a new vulnerability. So yeah, really really good for them. As an extra protection, besides of course applying the patch, an extra recommendation will be also to keep firewalls and all your security endpoints that you have updated, because we are dealing with HTTP issues. So here, for example, if you have a firewall in the maybe the firewall will have detect the reverse the web shell and will block that attack. So it's always a good advice and good recommendation to have all those security endpoints up to date. Now I will leave Ignacio to continue with the following topic.
Forecasting the implication of these new critical vulnerabilities that were about to be published, most of them targeting potential internet exposed solution. I can mention, for example, the solution manager or the SAP Java stack system, along with some previous vulnerabilities, really old vulnerabilities that are still being exploited in the wild nowadays. Onapsis decided to take the lead into this threat intelligence campaign. As we mentioned before, the SAP systems are mission critical systems, which means that manage or handle financial records, transactions, customer records, so very important information from the biggest companies around the world. So sabotage attacks and espionage attacks are everyday threats for these kind of systems. But beside these targeted attacks or from expert attacks, we found some other interesting reasons. For example, crypto miners or bounty hunters or botnets, which are more automated attacks and massive attacks that could lead to a security breach in our SAP systems. These new rules in the technological environment, for example, anonymous payments and anonymous networks, and some BPS in the cloud services that give the feeling of anonymity in the internet connection, bring new players to this game. So not only expert attackers are actively exploiting or trying to exploit these vulnerabilities. Also, internet indexers give the information about SAP system exposed to internet. Joining all this information together, imagine that there is a lot of people trying to break into these kind of SAP systems. We have kept track of 7 threat vectors, and as a result of our threat intelligence campaign, we have evidence of more than 500 confirmed exploitations, with more than 100 with the attackers with their hands on the keyboard trying to access to the data or exploring the system. And as a key takeaways and implication, the threat actors are actively targeting and exploiting unsecured SAP applications, and some of them possess a lot of expertise and capabilities to carry out really sophisticated attacks. Besides that, the window to defend is getting shorter. For instance, the exploitation for RECON started in less than 72 hours that SAP released the patch. And also, new SAP systems that were provisioned in cloud environments has been discovered and attacked in about 3 hours. But the attacks are not only targeting missing SAP security patches, but also, for example, misconfiguration, as could be default credentials or misconfigured ACLs. And finally, these threats not only represent a cybersecurity risk, they also could have some compliance implication in SOX or GDPR. Well, some fun facts during our threat intelligence campaign was, for example, that after exploiting RECON and successfully creating a user, the attacker applies a workaround to protect the SAP system. So I think that maybe not all here were capes. But someone else that was able to execute a OS command of using a really old vulnerability did it just to run a Monero crypto miner. And finally, we have evidence that some vulnerable endpoints were tested around 3 months before the exploit was publicly available. And concluding this presentation for today, I want to share with you the list of vulnerabilities and patches, but also I want to emphasize that combining some of them, for example, RECON with the Java RCE or Cluster Manager with the Java RCE, is possible to perform an authenticated remote command execution. And as a conclusion in itself, We have that critical exploits are becoming publicly available. And maybe because of this or the public attention on the new technological rules that we share with you during this presentation, attacks on SAP systems are getting more and more common. And on the other side, we have that finding bugs in SAP is getting harder. This is sample as how important the security is for SAP, and also along with this, SAP patches are being released faster and system getting stronger. So ensure, but you need to ensure that you have your system as updated as possible. And I want to thank you, and I hope that you have enjoyed this presentation. Bye bye.